118. Why? The value of e and the output of function exp is perfectly same. Just see, if I write percentage e raised to 2, that is e square 7.389, okay, I'll write exp 2, same result. So effectively exp function and e are two exactly same things. Okay, exponent over logarithms. Let's write log 2, 0.693. What is this? This is a natural log, or we call it Neperian log, right? So this is a log with base e. Log 2 to the base e, the value is 0.693. We all know that. Now what if I want to use log with base 10? I'll write log 10. Log 10 of 2, 0.3010. Oh, I got some error. Okay, forget. Something went wrong. I need to restart Scilab. Sorry for that. Scilab. Okay. So log 10 2. Oh, I forgot to zoom in. You can't see. Yeah. Log 10 2. 0.3010, right? So this is log 2 to the base 10. Again, if I write simple log 2, it will take the base as e and I will get the answer 0.693. Okay, so this was a quick review of which functions: mathematical, that is algebraic functions, trigonometric functions, logarithmic functions, exponential functions, and the mathematical constants. Right, now these things are very simple. You need not even, let's say, practice them also. You just remember them and you are done. Okay, one small thing lastly, I can use variables also. For example, I write a is equal to 1, I write b is equal to 2. Okay, so output is a is equal to 1 and b is equal to 2. Now suppose if I write a plus b, answer is 3. So the value of 1 and 2 are stored in the variables a and b. Good enough? Okay, I can store this value in c also. C is equal to a plus b, let's say. So value of c is now 5. You read it? C is equal to 5. If I write c over here and press enter, I'll get the value 5. If I write b over here and press the enter, I'll get the value 2. Good? So the values are stored in variables. Now these cannot be just natural numbers, these can be real numbers also. You can store a is equal to 0.1 and b is equal to 0.2, add them, you get c is equal to 0.3, right? So this was a quick review, but now let's get into some serious calculations. Now you are quite well aware of how to use Scilab, so let's get into depth. Let's start working with vectors and matrix. So I hope Neil will take over. So Neil will start teaching you vectors and matrices.
Okay, good afternoon everyone. As my friend Tadrash has already taught you how to install Scilab on your computers, even on your laptops. He has explored some basic functions, how to use Scilab, how to play with it, what the type of console it shows and all that. Now let's get into some deep. Let's learn about how to play with metrics and vectors. So first of all, we will start with vectors. Now, as being a science student, you all must know what is a vector, and usually we know that a vector is a quantity which is having measurement as well as the direction. Now in case of using Scilab to play with vectors or to manipulate the vectors, there is one convention that vectors are always given the name in the small letters. Okay, so please do remember, it is not mandatory, but as being a science student, we must follow the conventions. So it is the convention that to assign or to name a vector, we always use small letters of alphabetic letters. Now let's start with how to define the vectors on Scilab and how to perform various operation using the vectors. So have a look at on your screens. Control 4.
4 live zoom.
Okay. So now for vector, as I say, we are going to use the small letters. So let me first define one vector. How to define the vector? Let us see. Let's name the vector as P. So P equals to, open square bracket, let's say first element 1 space 2 space 3 bracket close, enter. So it will show you that the vector has been assigned values 1, 2 and 3. You can also assign vector by separating the elements using comma. Say for example, Q equals to 1, 2, 3 bracket closed. Okay, so P and Q having the same value. Now let's say we want to find how many elements are there in our vector. Let's say we want to find the length of P. So as of now we know that there are 3 elements in vector P, that is 1, 2 and 3. So now let's calculate the length. So for that the command is LENGTH, simple length. Okay, in small bracket write your vector name P, bracket close. Remember one thing, whenever you are manipulating the already assigned vector or matrix, anything, you have to put the round brackets. Okay, do not use square brackets over here. Press enter, it will show as 3. Okay, suppose we change P equals to 1, 2, 3, 4 bracket close. So now my vector P is having 4 elements, so length should be of 4. So let's say again try LENGTH, sorry, of P, enter. Okay, so in the first session it shows as 3, and in the second it shows 4. Okay, now suppose I want to add 2 vectors. Okay, so let's assign new 2 vectors. A equals to say 2, 5, 7. Okay, and B equals to 3, 6, 9. Okay, so 2, 5, 7 and 3, 6, 9. Now if we add 2 vectors A and B, what should be the answer? It should be 2 plus 3 equals to 5, 5 plus 6 equals to 11, 7 plus 9 equals to 16. So first element will be 2 plus 3 5, second will be 5 plus 6 11, and the third will be 7 plus 9 16. So let's check whether the Scilab gives us the correct answer or not. So we just simply need to write A plus B, enter. 5, 11 and 16. Okay, that's good. Here it only shows the answer. Now suppose I want to store this answer in a variable. I want to define a new vector that is having the values of A plus B. Then what do we do? Let's say C equals to A plus B, enter. Okay, so it will shows that C equals to 5, 11 and 16. Okay, now if I type C, enter, it will shows that the element of C are 5, 11 and 16. Okay, same can be done to subtract the elements. Okay, we will try D equals to A minus B, enter. Minus 1, minus 1, minus 2. Okay, and these values are stored where? In the D variable. Okay, now say my D vector is having 3 elements, minus 1, minus 1, minus 2, but these are in the row major order. Okay, for vector it is always be a single unidirection, so it will be always having a single row or single column. Now what we have to do if we want to get the transpose of this vector, okay, that means that the value of the row should be placed in the column, in the respective columns, okay. So let's check how to calculate the transpose. Simple operation, simple terms. Press D and press the key of apostrophe, okay. Click enter. It will show the elements of D into the column manner. D and apostrophe symbol. This is how you can calculate the transpose. Simple thing, no need to do any extra calculation, okay. Matrix का ऊपर से matrix का नहीं, okay. Now to do multiplication. How to do multiplication, okay. As of now we are having D transpose, okay, and C vector, okay. Now let's say we want to multiply these two vectors D transpose and C. We will write D transpose multiply by C. Click enter. It will show you one matrix. As always, you know that a dot product or the multiplication of a row major vector and the column major vector is always a matrix, but it is mandatory that both of the vectors should have same number of elements in either row or either column. Now one thing I forgot to tell you, that whenever you are assigning any value in the element, or whenever you are assigning the elements of a vector, it will be always in a row major order, okay. When we talk later about the matrix thing, you always have to put the elements into row major order. What that means? It means that you have to enter the elements of the first row first, second of the second row, and thirdly of the third row, okay. So as of now, suppose this matrix you can see. So if I am supposed to enter the values of this matrix, I have to first insert this minus 5, then minus 11, then minus 16, semicolon of second row elements, minus 5, minus 11, minus 16, semicolon, minus 10, minus 22, and minus 32, okay. So now we will look for some basic scalar operations that Tadrash will teach you how to do that. So let's have a look at those scalar operations also.
Okay friends, I'm back. Okay, so now you all have seen that we use two vectors A and B, right? Now vectors can be multiplied in two ways. These can be a scalar multiplication as well as a vector multiplication, right? We call it dot product or cross product, right? Scalar and vector multiplications. Now let's see that is something really important. Okay, I will write, let's say, a new vector A as 1, 4 and 6, right? So now you know how to write your vectors. Okay, I'll put B as an identity vector with all the elements as 1, simply because I can verify the results, okay. So I have A, oops, sorry, I made a mistake. It is B is equal to, I forgot to place a is equal to sign and enter. Okay, so I have vectors A and B now. I'll just show them again to confirm that I have the values stored in them. A 146, right. B 111, okay, right. Now let me take transpose of A, so that is A apostrophe or A dash as you may call it, 1, 4 and 6. Okay, now how to multiply these two vectors? Important question, right? So A dash or A apostrophe, I will call it A dash because apostrophe is a bigger word and difficult to even pronounce. So A dash, simple. Okay, so A dash is a column matrix, you can say, of 3 cross 1, 3 rows 1 column, while B is a row matrix of 1 cross 3, so that is 1 row 3 columns. So when I multiply A dash with B, A dash into B, so that is a matrix 3 cross 1 multiplied with a matrix 1 cross 3, so result has to be 3 cross 3. Let's try A dash star B. Is it there? See the values. Good enough? 1 1 1 1 4 4 4 6 6 6. So because B is an identity matrix, right? We just put B as an identity matrix. Why? So that we can verify the results easily. So if I do A dash into B, I get a matrix 3 cross 3. What if I do A into B dash? A into B dash. 11. Just 11? Yes. Why? What was my A? What was my A? It was 1 cross 3, 1 row 3 columns. What is B? Again 1 cross 3, but here I used B dash. So B dash will be 3 cross 1. How? Let me show you. Yes. 3 cross 1, 3 rows 1 column. So A into B dash 1 cross 3 with a matrix 3 cross 1, so result has to be 1 cross 1. And what the result was? A simple 11. So this was a scalar multiplication. Was it scalar? Yes. 6 into 1 6, 4 into 1 4, 1 into 1 1, so 6 plus 4 plus 1 11. This was scalar multiplication? Yes, it was scalar multiplication. Oh, and what the result just before that? A dash into B. It was a vector multiplication because it gave me an ultimate matrix. So it was a cross product. Which one? A dash into B was a cross product and A into B dash was a simple dot product. Scalar multiplication as well as vector multiplication. So these things has to be very clear. Now, pardon us because we won't going into those details of mathematics and the vector theory, because that's something that we have assumed that you have digested the vector theories and the multiplications good enough so that you can understand these things. Okay, now I have one question. I did all the calculations today, some 20-25 of them. You saw all of them, right? I need to save them so that tomorrow somebody can refer them.